pension fund has $30 million to invest. The money is to be divided among treasury notes, bond, and stock. The rules for administration of the fund require that at least $3 million be invested in each type of investment. At least half the money be invested in treasury notes and bonds, and the amount invested in bonds not exceed twice the amount invested in treasury notes. The annual yields for the various investments are 7% for treasury notes, 8% for bonds, and 9% for stocks. A. Formulate a mathematical equation from the word problem. B. How should the funds be distributed among the several investments using the graphical method in order to maximize return? So in question 1, I gave a scenario of making the most out of 10 Ghana cedis to eat 3 times in a day. This time, we are not eating. We have $30 million to invest. And how are we going to make the most out of it to get a maximized return? This time, I'm using a graphical method. So, to the solution, let's represent X as the amount invested in treasury notes, Y as the amount invested in bonds, and then Z as the amount invested in stocks. Again, X plus Y plus Z should give you 30 because you know that the money that was given is $30 million. Alright? At least $3 million must be invested in each type of investment. What this means is that we have X greater than or equal to 3, at least. Y greater than or equal to 3, at least. So that means greater than or equal to at least, right? We have Z is greater than or equal to 3. Now, one thing with the graphical method is that for 2 decision variables, the graphical method cannot support more than 2 decision variables. But in this problem, we've been given 3 decision variables, X, Y, and Z. So in order to use the graphical method to solve this problem, we need to convert the Z variable into X and Y. So how do we represent the Z variable in X and Y? Since we know that X plus Y plus Z is equal to 30, meaning if I add X plus Y and I subtract from 30, it should give me the value that is greater than or equal to 3. So another way of representing Z greater than or equal to 3 is 30 minus the sum of X plus Y greater than or equal to 3. That is how we represent the Z variable. And then when I simplify this equation here, I'm going to get X plus Y less than or equal to 27. There is a change in the inequality sign because of the negative sign. You have to multiply both sides by -1, which changes the sign. Let's continue. So the major thing to note about this problem is that the graphical method supports only 2 decision variables. Anytime you have more than 2 decision variables, you need to convert them into X and Y or into the other variables. Again, at least half the money must be invested in treasury notes and bonds. So half the money is 15, and they said at least, that means greater than or equal to 15. So X plus Y greater than or equal to 15. Another constraint is that the amount invested in bonds must not exceed twice the amount invested in treasury notes. Treasury notes is represented by X and bonds is represented by Y. So Y should not exceed, so Y less than or equal to twice the treasury notes, so 2x. So how do we optimize this equation? Our equation is 7% of X plus 8% of Y plus 9% of Z. Now you can see that I've represented it with 0.07, 0.08 and 0.09. This Z part, we are going to change it in the latter part of this video. So don't worry if you are seeing Z here, we are going to change it to 30 minus X plus Y, alright? That is in brackets. So let's continue. So with these constraints that I've been given, the constraints that we have here, I'm going to draw out a graph out of these inequalities or these equations that we have here. So if you go down and we look here, you can see I have this beautiful graph over here. So the first constraint was that x was greater than or equal to 3. So that is the vertical line you see over here. And then we have y is greater than or equal to 3, which is represented by this horizontal line you see down here. Okay. We have z is greater than or equal to 3. And I told you that this z part is going to be the x plus y less than or equal to 27. So how do we represent that on the graph? If you have x plus y equals 27, when I say x is equal to 0, I'm going to get my y to be 27. Right? And when I put y to be equal to 0, I'll get my x to be 27. So I'm going to plot 27, 0 on the x-axis, and then 0, 27 on the y-axis. So that is how, and then I'm going to connect them. That is how I get this line over here. The next step is I have x plus y is greater than or equal to 15. So from that, if I put x to be 0, I get y to be 15. And when I put y to be 0, I get x to be 15. Right? So I'm going to get 15, 0, and then 0, 15. So if I do it correctly, I'm going to have this line over here. So 15, 0 on the x-axis, and then 0, 15 on the y-axis. I'm going to connect them to draw my line. Then lastly, I have y less than or equal to 2x. So which is actually y equals 2x. That means it has a slope of 2. So I'm going to draw out a line that has a slope of 2 coming from the origin. The origin is the 0, 0 down here. Alright, so I'll pick any point. Let's say x is 15. If x is 15, the value of y is going to be 30. So if I pick a point 15 here and then 30 on the y-axis, and I draw a line from the origin to that line, to that point, I'm going to get a line that has a slope of 2. You can pick any value for x or y, and then you should still be okay. Alright, so now we are done with drawing out our graph for this the set of constraints that we were given. Now the next thing to look out for is our feasible region, the region that gives us the maximum output. So you can see that I've made some 4 labels here. We have A here, we have B over there, C, and then D. So this is our feasible region. You can see that x plus y is greater than 15. So we are looking at the top of this line. And then x plus y is less than 27. So we are looking at below this line, which gives us this feasible region. Alright, so among the corner points that we have, 5, 10, 12, 3, 24, 3, and then 9, 18, which of these corner points will give us the maximum output when we put the corner point inside our formula? That is our objective function. If we put it inside our objective function, which of these corner points will give us the maximum output out of our investment? So I drew out a very nice table down here with the values inside: x, y, z, and then our objective function. So if you have x and y and then z, we have our objective function over here. We have all of them and their corresponding values. So if you look at the corresponding values of our corner points, we can see that the one that gives us the maximum output is 5, 10, and 15. And that the value given is 2.50, which is 2.5 million US dollars. Alright, so that we can conclude now that the maximum return occurs at the point B, which is 5, 10, and 15, with a return of 2.5 million US dollars. And therefore, the optimal distribution of funds remains as follows: 5 million in treasury notes, 10 million in bonds, and then 15 million in stocks. So this is how we use the graphical method to optimize and bring out the maximum output from a set of constraints that we've been given. So remember, the graphical method only supports 2 decision variables. If you have more than 2, ensure that you switch the other decision variable to represent the other 2 decision variables. Alright friends, so that's basically it. Hope you understood. If you have any questions, be sure to leave it down in the comment section. I'll be willing to reply. Don't forget to subscribe.